Okay, section 12.4 was angle measures and segment lengths, and this was broken into two sections. Angles, we said if the intersection is inside of the circle, then the measure of the angle is 1/2 your left arc plus your right arc, your intercepted arcs, half the sum of your intercepted arcs. And if our intersection point is outside of the circle, it is the measure of the angle is 1/2 the difference. So that's the 1/2 times the measure of the outside arc minus the measure of the inside arc. And then we also said that segment lengths are the product, so multiply, of your point to the left side of the circle times your point to the right side of the circle. Now, there's quite a few problems here in section 12.4, but we'll see if we can't get through them kind of quickly. So we are told that assume that lines that appear to be tangent are tangent and find the value of the variable. All right, so we are looking at angle x here, and I can see that its intercepted arcs are here and here. It is inside the circle, so the measure of our angle is 1/2 left plus right, so x equals 1/2 of 140 plus 85. That is 1/2 225. So x equals 112.5 degrees. That's not very convenient. That's all right. And y here, well, how are we going to find that? There's a number of ways we could calculate what these arcs measure because we have a diameter here, so we know that both of those sides are 180, but I am going to go back to the beginning and say we have a linear pair here, and x plus y is 180, so 112.5 plus y equals 180. If I subtract 112.5 from both sides, I get y equals 67.5 degrees. That was easy. All right. Okay, where's the next one? Okay, this time our intersection point is outside of the circle here. That we have a tangent line. The measure of our angle is equal to 1/2 the difference of out minus in. So we have an outside arc and an inside arc. We know our inside arc. We can find our outside arc as well. We know that x plus 95 plus 72 is going to be an entire circle. All right, so I'm going to subtract 167 from both sides, and x is going to equal 193 degrees. So I know this is 193 degrees, and that's going to let me find my angle y. Not changing colors here. Y is 1/2 of 193 minus 72, so that is 1/2 of, that's 121 degrees, so 60.5 degrees. 0.5 degrees, there we go. All right, next problem. We have an intersection point on the outside, only this time we are looking for a segment length. So we know that we want left times right equals left times right. So we need to find where our lines intersect our circle. We know that one of them is tangent, so that is just going to be x squared here because both of the lines are the same length, and that is going to equal, we do the entire distance, 18 times to the right point is 6. So x squared equals 108. Don't forget to square root both sides. We could definitely simplify this radical. That is going to be 9 goes into there. Square root of 9, square root of 12. Well, 12 can be factored to 4 and 3. So that is 3 times 2 times root 3. So x would be 6 square root 3, which would also be 10.4 in decimal form. We have our angle. We are looking for arc measures. So we are doing our angle stuff. We know the measure of our angle, our point is outside, is 1/2 out minus in. So we have an outside arc here, tangent line, and an inside arc. Okay, well, how are we going to do this? We know the inside arc is x. How are we going to figure out? Well, we know that 360 minus 120 is 240. So I know that this whole arc here is 240 degrees. So if this is 240 degrees and this one is x, then I can say that y is 240 minus x. So I can use that, and I can do the measure of my angle. I have a space right here. 30 is 1/2. My outside angle measures 240 minus x. And then be careful, because now we have to subtract the inside measure here, which is x. All right, then we get 30 equals 1/2 of 240. I'm going to combine my like terms and get minus 2x. And then I can either distribute or multiply by 2. Distributing looks good. 30 equals 1/2 of 240 is 120. Minus 1/2 of 2x is just x. And then subtract 120 from both sides. I get a negative 90 equals a negative x, divide both by negative 1, and that is going to give me x equals 90 degrees, and that will allow me to find y. Y is just 240 minus x, so y is 240 minus 90, so y is 150 degrees. All right, those weren't too bad. Let's look at what's next here. We've got some more of the same. Why don't you pause the video and you try the next two, and we'll come back and go over them together. All right, these both dealt with segment lengths, and both of them have the intersection point of the lines outside of the circle. So we're doing the distance to the left point times the distance to the right point equals distance to the left point times distance to the right. So on this first one here, I started with the x value, and that is the blue angle here. So from the point to the left point is x plus 5 times to the right point is 5, and the bottom line is 15 plus 7 times short one is just 7. Just do my multiplication, opposite operations, and I get x equals 25.8. And then that allows us to put that value in for x, and we see that the green one here, the top angle, it has a tangent, so we know that's y squared, and equals, now we have a value for this point, 25.8 plus 5 times the short part there is just 5. Again, just do the math. Don't forget to square root your y squared, and we get y is 12.4. And the next problem, the first part, x is one of our interior intersection points. We are inside the circle there. So it's still a left times right equals left times right. So I do a 3 times 13 equals a 7 times x. Do your math, and x is 5.6. The other angle intersects outside of the circle. And so this length here is 16. 3 plus 13 is 16. So 16 plus the short part, 6, is y plus 7. Right, we'll just add those together, times our short part on the outside is just 7. Then it's just algebra again, and we get y is 11.9. Okay. Pause the video and do the next two problems. They look a little more complex. I still believe you can do them. These look like angle problems. Okay, hopefully those went pretty nicely. The first one here was a little bit difficult to see, but you just have to pick out the specific lines that you're interested in. First thing we wanted to do was find the measure of angle x there, and we know that it is an interior intersection inside the circle. So I marked my angle x, and I found my that my lines, my left arc is this semicircle over here because it intersects right here at the diameter, and my right arc, it was missing over here, but we found it because we know that this is a semicircle. So 180 minus 70 minus 60 gives us 50. So I can do x is 1/2 the left side, which is 180, plus the right side, which is 50. Half of 230 is 115. Right? Then we are doing the outside arc. And the outside arc, we know that we need our intercepted arc here and our intercepted arc here, because both of these things are intersecting our circle right there. And this one is right there. So the measure of my angle is 1/2 the difference of those two. So I just plug everything in. 50 is 1/2. I know my outside arc is 180. My inside arc is y. Do the math. Y is 74 degrees. That one was a little more challenging, but if you're careful, you can work your way through them. All right, this one, next problem. A is just an inscribed angle, and we know its arc up here is 110, so half of that is 55. B is also an inscribed angle. It's our tangent inscribed angle, but its vertex is still here on the circle. So it's half of its arc, but we didn't know its arc, but we see a diameter, which means we have a semicircle. So subtract 110 from 180 there, get 70, and then that B angle is just half of 70, which is 35. Now angle C was a little more challenging. Angle C is up at the top here, right there. But I see 2 radii, which means we have an isosceles triangle. So I pulled my isosceles triangle out here. I know that both of these angles are congruent by the isosceles triangle theorem, which means I can look at this angle down here, and it will be C as well. And it has an intercepted arc up here of 60 degrees, so half of that is 30. Now, another way to look at this one would have been to look at, we have a central angle there, which is congruent to its intercepted arc, would be 60, and we have a linear pair. That would make this 120, which means 180 minus 120 is 60. Divide that by 2, and I'm going to get my 30 degrees again. All right. those were some good practice. Time to move on to 12.5. 12.5 was circles in the coordinate plane. This means we are using distance formula. Now let's write down our equation of circle first. Equation of circle is quantity x minus h, quantity squared, plus y minus k, quantity squared, equals r squared. Your center is at hk. Alright, and our old friend, the distance formula. Distance is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And we know how to do that. All right, what's our first problem from us here? Write the equation of a circle with the center that is at P. All right, well, there's our center. So we label H and K, and we're given a radius of 7. We simply write our formula, x minus h, quantity squared, y minus k, quantity squared, equals r squared. We substitute in. Do not forget that these equations are minus from the beginning. So x minus 9, quantity squared, plus y minus k is negative 3 squared, 7 squared. Final answer, x minus 9 quantity squared plus y plus 3 quantity squared equals 49. Don't forget to square your r. Okay, the next one gives us a point through another point. Well, we have not only hk here, but we could also call that x1, y1, and x2, y2. And we need to find r. So we use our distance formula to find r. It's the square root of x2 minus x1. That is a negative. Be careful there. Squared plus y2 minus y1 squared. Okay, that equals square root. 2 minus negative 4 is 2 plus 4. So that's 6 squared plus 1 squared. All right, 36 plus 1. Oh, that is unpleasant. A radius is the square root of 37. But we remember we're going to square our radius, so that's okay. That's going to get rid of our square root. Do not turn those into a decimal. So then we just take this, we take our r, we write our formula for a circle again, x minus h, x minus k, both of those squared equals r squared. X minus, don't forget minus, what was h? It was a negative 4. Y minus k is 0 equals the square root of 37, and we square r. So we get x plus 4, quantity squared, plus y minus 0 is just y squared, and the square of a square root is just the number itself. So there's the equation of that circle. And our last problem says find the center and the radius. We know that our equation is x minus h, y minus k, and r squared. So our center, x minus 1, so h is 1, and y minus k, how do we get minus k? It's minus a negative 2 would make a positive 2, so k is negative 2. And how do we get r? Well, r squared, we know, is 25. Square root both of those. R is simply plus or minus 5. We know negative is not going to work, so r equals the positive 5. There's our center and our radius. All right, circles in the coordinate plane are really rather easy. I know the distance formula can take a little bit of effort, but not a problem. Be careful when you are looking at the segments and the angles. Interior angles are not always central angles, so be careful with those. Um, just use your colors, mark what you're after, and it will all go well.